So, here's your first problem. And like I said, it's just an extension of yesterday. When you get a common denominator, or the same that we've done forever, is you have to factor the denominator. Okay, so the denominator here, we're adding fractions. So in order to add fractions, you have to have a common denominator, right? But in order to look at it to be nice and pretty, we're going to take this and we're going to get it in its basic form, which would mean I would take this out and make it 2 times x plus 1, right? Now, on a more basic level, if you're going to think about something for a second, if I told you 2/3 plus 1/4, what's my common denominator here? 12. You want a 3 and you want a 4, right? Which gives you 12. So your common denominator is 12 because I need a 3 and a 4. We multiply them together, correct? But 3 times 4 is very simple. It's just 12. But regardless, 3 is a factor of 12 and 4 is a factor of 12. Okay, but because 3 times 4 is 12 so simple, it's easy. In this situation, okay, I need factors of both, but I don't want to multiply them out. Okay, I need an x plus 1 from this side, right? Kind of like you would need part of a 3 from this fraction. And on this fraction, I've got a 2 and an x plus 1, correct? So over here, I want a little bit of both. I want an x plus 1, and I also want a what? A 2. Because now, hang on, and I'll show you what that means. If you go back and you pull it together, you can glance at it and say, okay, x plus 1, yeah, it's a factor of this. This denominator is made out of 2 factors, a 2 and this. Kind of like 12 is made from the 3 and the 4. Okay? So this is made from the 2 and the x plus 1. You'll see it? So x plus 1 is a factor. Now go to this side. Does it have a 2 in here? Yes, I'm good. And then there's your x plus 1 also. So you've got everything you need. And it gets easier. Let me do one more and you'll pick up on it, okay? Now to compare, if I look at these two, this denominator has a 2 and an x plus 1. So the denominator had to be multiplied by 2. So we do the same in the numerator, multiply by 2. So 2 times 6 is 12. Now for this side. This matches already, so we're just going to take the 10 and pull it over. So 12 and 10, 22. Over 2 times x plus 1. Does anything cancel?
Yeah.
Yeah, you have to look, because I'd say about 40% of the time something cancels. Not always, just enough for you to think, okay, nothing's canceling, and then all of a sudden it will. So be careful. So these go away, and you end up with 11 over x plus 1. And for your restrictions, x can't be negative 1. Number 2. X over x plus 2 minus 3x minus 4 over x plus 2. First thing you got to be careful of is the subtraction. Remember, you can change it to addition and move it over on both. You don't want to forget that. Now in this particular problem, what do you notice? What do they already have? Yeah. What is their denominator? They're both x plus 2. So just put your x plus 2 here and just move the tops over. And if you got this far on a test and you boxed it, okay, would you earn full credit? No, almost. All but like 1 or 2 points. Because what would happen? What actually can happen in the numerator? It's kind of sneaky, but yeah. And remember, yesterday we weren't really able to factor too much. You just got to look at each one. Everyone's different. So you can take a 2 out of here to give me an x plus 2. And then the x plus 2 is actually cancel. So the final answer is just 2. And your x can't be negative 2. Number 3. 9x over x minus 10 plus x over x minus 3. Okay, this looks kind of messy, but it's, if you're trying to get a common denominator, if, for pretend, if this were 4 and this were 3, a common denominator would be 1 of each, right? So it would be 12. Agree? Well, just because it's fancier doesn't change the rules any, right? If I, instead of using little numbers, I'm just going to use big numbers. I need this and this. Now, I could multiply them together, FOIL it all out, and I would get like x squared minus 13x plus 30. But why would I want to FOIL it? What am I hoping that's going to happen? Like, I did 3 times 4 and wrote 12. But in this situation, I'm not going to FOIL them all out. I'm just going to come over and I'm just going to write them down. I'm not going to actually do the math to FOIL them. Because I'm going to hope one of them does what? Cancels. Okay? You always factor to see if something cancels anyways, right? So leave it factored. Now then, let's see. Is x minus 10 a factor of this? Yes. Right? But it now needs an x minus 3. So you get 9x squared minus 27x. This side needs x minus 10, giving you x squared minus 10x. You're going to combine like terms, so you'll have 10x squared minus 37x. Okay, you can check it. If you take an x out of here, you're going to get 10x minus 37. Is it going to help us any? No. So there's no reason. If you tried to factor and it didn't help any, just don't even worry about it. Okay? So that's your final answer. Does it have restrictions though? Yeah, 10 and 3.
Plus.
Number 4. $13x over x squared minus 5x plus 6. It's a subtraction, so let's take care of that so you don't make a mistake later. We have to do all this fancy algebra and forget just subtraction, right? Okay, now, can I factor anything to help me with my common denominator? Right? If something factors, factor it. It will help you look at it at a easier level, okay? Basically what we're trying to figure out, and I'll show you for a second, I want to know if x minus 3 fits into here, if it's a factor. Do you guys remember we did like synthetic division and long division, right? And on the simple term, if I had 12 and then 3 and 4, I could say, okay, 3 is a factor because it divides in, and 4 is a factor because it divides in, right? If I factor this, I could divide if I want. I could say, what is x squared minus 5x divided by x minus 3? What's an easier way to see if it fits in or not? Rather than dividing. What could I do instead? Yeah, I could just factor it and see if it's a factor or not, right? Kind of like we do with 12. I could list all the factors of 12. 1 and 12, 2 and 6, 3 and 4. Oh yeah, 3 and 4 are factors. It's the same thing. So factor that. And you get x minus 3 and x minus 2. Was it a factor? When you divided, what would you have gotten? X minus 2. So my common denominator is a lot easier now. This fraction here has a -3 and -2, this one has -3. So what's my common denominator? Yeah, an x minus 3 and an x minus 2. Okay, so my first fraction, I've got one of each. I don't need anything, so I'm going to slide my 13x over. On my second fraction, what does it need? Yeah, an x minus 2. And guys, I could have written this over there, couldn't I? That's a lot harder to work with. See how much easier they are to work with already factored? It needs an x minus 2. So you get 8x plus 10. Okay, the top factors a 2 out, and you'll get 4x plus 5. Does that help you any? No, so just leave it alone. Number 5. Alright, number 5, they both factored. Okay. So try it. What's the first one factor into? What can you take out of the numerator? I'm sorry, the denominator. Mm-hmm. This becomes x times x minus 3. This becomes x plus 3 times x minus 3. Now to get a common denominator, kind of like before when we used 12, we need a 3 and a 4, don't we? So we need a little bit of everything. Because I want all these factors to be part of the answer. So I need an x. What else do I need? Excellent, an x minus 3. Now come over to this side. There's my x minus 3. So if I'm going to divide, this would fit in, but what's not there? The first fraction then, of course, needs to be multiplied by x plus 3. So you need 3x plus 9. And the second fraction, what does it need? X. Just an x. Look, these are here. It just needs the x. So 5x plus 9 over this whole thing. There you go. X can't be 0, 3, or -3. Alright, number 6 is tricky. So you're going to start by number 6. We get a subtraction, so take care of that. And I'll give you a second to practice your factoring. Factor both of those. Many know what that x squared plus 14x plus 49 is called. It has like a special name. What?
Perfect time.
Good job.
That's good.
So
Cool.
yeah, it is. I'm so proud of you. It's called a perfect square trinomial. Because when you factor it, what did you guys get? I'm so proud of you.
fancy name.
Yeah, it's just a fancy name, and it's because when you factor, you get x plus 7 times x plus 7, right? It's a perfect square, actually. It's x plus 7 squared, and when you get it, you get a trinomial. Right, now, this side then turns into x plus 7 times x minus 7. That's the difference of perfect squares. What's different about this problem? Yeah, on the first fraction, I've got 2 x plus 7s. Every other time I had 2 of something, one was on one fraction and one was on the other. Do y'all see what I'm saying? Mm-hmm. So when you get ready to make a common denominator here, let's take a look at the first one. How many x plus 7s does this fraction actually require? 2. This side needs 2 of them. Right? In order to meet the requirements of this fraction, it requires 2 of these. So there they are. Now go to the other side. Let's check. Does it have at least one x plus 7? Yes, it fits it. Does it have an x minus 7? No. So you need to add that. Okay, if you don't see the connection, let me go back to like problem here. Let's see if I can find one. This. Look at 4. On 4, this one has only one x minus 3. Here I've got 1 in my answer. This has 1, and I have 1 in my answer. You see it? Versus this problem, this side has 2, I've got 2. This has 1, yes, I've got at least 1. And this has one of these, and I've got at least 1. That's tricky. Right, now then let's finish up. This needs an x minus 7, giving me 5x minus 35. This needs another x plus 7. Okay? Now combine them. We have 2x minus you can write x plus 7 squared here to save you some time. Now then, see what you can do next. Right? Did you do anything to it? Good. I can take 2 out. Does this help? No. And let me kind of get you thinking in the terms of an AP test and what Kilcoyne will tell you later. I can take the 2 out, and I can go ahead and write my 2 taken out. But if I accidentally make a little mistake right there, guess what they're going to do? They're going to dot me in points. So take it out and see if it helps maybe. But if it doesn't help, when you write your final answer, go ahead and write the non-factored one. So that if you do make a tiny mistake, you aren't going to get docked. Okay? So it didn't help me by taking a 2 out. So then just box your answer and you're done. Okay, number 7. Y'all are going to be so good at factoring, we should have followed this unit before you took your factoring test, right? Remember how hard factoring used to be? This will become x plus 7 and x plus 2. X plus 7 and x minus 3. Plus 3, sorry. The common denominator. How many x plus 7s do I need?
1.
Yes. Good job. I only need 1. There's 1 on one fraction and 1 on the other. The only time you need 2 is if one fraction has 2. Right? So one of them needs an x plus 7. I need an x plus 2 and an x plus 3. This fraction needs an x plus 2. giving us 8x plus 16. Combine like terms. And then your 27 and your 16 make 43. Okay, guys, 43 is not very easy to factor necessarily, right? So it isn't really going to matter. You can check and see, but if I took a 17 out of 43, I would either need for it to be 2, 3, or 7, right? So if I double 7, it ends in a 4. If I triple 7, it ends in a 1. So I don't even need to mess with it, because this ends in a 3. So it's not a factor. X can't be negative 7, negative 2, and negative 3. We're going to 10. We're getting closer. Here's 8. Okay, take care of your subtraction first, right? Factor the denominator. The common denominator then is going to be an x plus 2 and an x minus 2. The nice thing is the first fraction needs nothing. Second fraction is going to need an x minus 2. And the last fraction needs an x plus 2. Don't forget to distribute to both. So the x's give us 6x plus 12 over x plus 2 and x minus 2. If I box it though, what's going to happen? I'm going to do what? I'm going to lose a point. Do y'all see why? Yeah, it's kind of like just when you get complacent, right? Nothing factors for a while. All of a sudden, bam, 1 factors. You see it? Okay, you can't get complacent. This makes a third out of 8 that's factored. So this becomes 6 times x plus 2. So every now and then they do. And then the x plus 2's go away, so it's 6 over x minus 2. Alright, last 2. You guys, this is your last lesson of the year. I just noticed that. This whole entire semester. These are your last 2 lessons, last 2 problems to be lectured on. You got work to do, but does that give you some encouragement?
Is this recording?
I'm gonna shake you.
I wish I'd thought of that earlier today.
Bro, that's on the video.
I'm sorry that we got a lot more questions.
Okay. Subtraction, fix it. Factor. Get a common denominator. See what happens. Common denominator, x plus 5, x minus 5, and then x plus 3. This fraction needs an x plus 3. This fraction needs an x plus 5. when you combine like terms. Did anybody box that?
Nope.
Good job. Okay, you have to check. First of all, we talked about this the other day. When I showed you a problem, or we did problems a lot yesterday, and you would have like a trinomial on top, like maybe this, and a binomial on the bottom, like 2x. It's not going to do us any good to even try to factor that. Because once I do factor it, I'm going to get a set of binomials. I'm not going to factor with a monomial no matter what they are. Right? So it wouldn't do me any good. Now in a problem in this situation, I know it's going to create two binomials, so I better at least check and see if it factors. And it does. It becomes x minus 5 times x plus 4, and your x minus 5's go away. Do you see how kind of using some math reasonableness can kind of affect what you decide to continue to try or not? Right, so x can't equal 5, negative 5, and negative 5. Last one. Do you get any questions? A little bit like yesterday, right? With the twist of today. That's what this problem is. Okay? Complex fraction from yesterday, but the only difference is the denominators are just a little fancier. So what do you have to do first when you have a complex fraction? You have to get, one division bar on the top and one division bar on the bottom. How many division bars in this problem do we have in the bottom? 2. So we have to clean it up, don't we? So get a common denominator, make it look better in the bottom. It's not hard. I just wanted to show it to you so you'd seen it. So this is an x plus 3 and an x minus 2. Correct? This needs an x minus 2. So you get 2x minus 4. You need x plus 3 here, so you get 5x plus 15. You clean this up, you get 7x plus 1. What are we going to do now? A division bar on the top and a division bar on the bottom. So now what are you going to need to do? Yeah.
It's supposed to be cosmology 15.
11. Thank you. I just wrote 5. Better? Thanks. Now then, flip the bottom. So 1 over x plus 3 times the x plus 3 is canceled. X cannot equal negative 3, 2, or negative 11 sevenths. Okay, you're done.